Okay, my friends, this is going to be outstanding, outstanding. I was going to do a real short one, but they never end up short because you got to get into the details. Now, before we start, though, as you know, my face was torn to shreds by a nasty, terrible pricker bush. Look at these things. They should not allow that. They shouldn't be on a planet. What's this thing doing here? I have it in a microscope right now. It scares me just even to have it around me. I got caught in this pricker bush, and the damn thing got caught literally in my mouth. I'm not kidding you. I had to actually break a piece of this off. Snap it off like that, because once it gets in your mouth, it was stuck inside my mouth, in my lips. I had to break a piece off and try to get it back out. It was just, and I'm getting prickers everywhere. Because what happened was when I wanted to take the tree out, because it's just a nightmare, and this thing's big. These one of the ones that come out like this and they flare around like that. So I was trying to get underneath it. So I'm cutting pieces here and there, and all of a sudden I cut one and everything went slap right in my face, right in my mouth. I'm not kidding you. It was horrifying. It was really, really a very, very bad position to be in. Let's go with that. But anyway, I have recovered to some degree, and I am going to get rid of that thing forever. I'm going to put some kind of chemical on there that's just never going to grow in the Western Hemisphere again. Okay, my friends, it's going to be short, and I'm just going to show you. This is kind of amazing. This is called bricks embedded in exposed sandstone on remote rocky mountain. Now, this is Australian history seeker. Now, he's got only 177 subscribers, but you should go up here and subscribe. I'm going to subscribe right now. I'd like to see what he has to say. He's a history seeker in Australia. I do a lot of, looking into things in Australia. I've never been to Australia. I never plan to go to Australia, but I don't have to be there to understand what I'm looking at. And I think I might understand this. So, plus you want to ring the bell here too. So you get all of this, whatever he's posting here. Now, I am going to go, don't forget, Australian history seeker. Now, he's coming up over this ridge here. It's only 1 minute and 14 seconds. I got to run really, really slow. Here he goes. He's coming up over the ridge. Now, look at here. And then look at here. I'm going to stop it right here. That's membrane. That is absolutely no question in my mind. That's some kind of a membrane. It's not just like that for no reason. This looks like somebody did it, but in my opinion, no. That is biology, but boy, I tell you, that's about as amazing as I've ever seen. Look at this. There's no question about it. It's not like a beehive or anything. That is what's in the interstitium. Now, this, and there's another layer here with a thin layer between. I think this might have been an artery or something. I really don't know. It really is strange. All right, this is some kind of layer below. And whatever was in here washed out, and whatever was in here washed out. Now, I look at the ends of things and the broken parts, and these aren't broken. These were made in blocks. But that's not unusual. I mean, it is unusual not to see it. Usually you see them in a pattern, but there's more stability if they're offset. So maybe it was. But I'm telling you, this is biology. That is basically the same thing. I'm almost sure this is an artery, and here's why. Let me show you what I'm going to show you. All right, so here we are coming down into the, I believe this is an artery, and I'll show you the picture of the artery, and I have an artery right here, and we're going to be seeing this kind of effect right up in here. Of course, this is nowhere near the size of that. Now, these blocks, I could understand that to a degree, and they do show, they do show there's a patterning, but they show them like a little different than this. But there's going to be layers of membrane in between each layer of the artery. Now, let me just show you what an artery looks like, and then when we go into here, maybe it'll make sense to what I'm thinking. And I'm just thinking. Now, this is an artery, all right? You see these walls here? You got a basement layer, and then you got those little square-looking things, triangular-looking things. And then above that, you've got this layer of tunica media, which is like the gooey stuff. Well, it's in the middle. All right, this is closest middle externa, and they're all layers of membranes and you know, things so that it can twist and move and still retain its structure and integrity and all that stuff. Very, very sophisticated little device. Now, I have another shot of it here somewhere. This one here. Now, you see there? External elastic membrane. They have membranes in between these, which I think is what eroded. And we may be seeing these, but as blocks, not as this here. I don't know why a lot of things, when they solidify, they turn into like shapes. And tendon turns into little strappy looking things. And this, I don't know what it would do. And I'm just guessing anyway, so it's just a guess. But I would think these membrane areas would leak out and you'd have a gap. And there's several different layers, and one of, you know, membranes have that little stuff that we saw in the beginning of the video. All right, so the membranes have this, and I think the whole thing is coated with some, I don't know, it's I've never seen anything like it there, I got to be honest with you. Very, very, I've never seen that. I have seen them, but not that tight. That is just as tight gets. You see it? Now, I'm sure it's biology, because there is nothing but biology, and I don't think anybody made this. And when you look up into there's where you have your blood. All right, that's like a bloody matrix up in there. I'm seeing some black, which is you're gonna see some black here and there. And here's your membrane area, whatever that was coating, or whether it just fell over or whatnot. Or this even could be, that maybe even is like a heart muscle. And this is the wrapping of the heart. Because there's a ton of blood. I mean, heart is just packed, first of all, with blood. Secondly, it takes a ton of blood to run a heart. Now let's pay attention to these things. You see this? That's obviously some kind of membrane there. What the hell is going on there? The line goes right through it. Wow. That line goes right through that, whatever it is. Boy, this is the strangest one I've ever seen. Look at that little line there, and nobody did this though. I'm sure. I can't imagine somebody doing this. Now, what is this? Okay, now we're getting somewhere. I think this is a heart, and I think this is one of the tubes of the heart. You see that blue like that? I think that's one of the valves. Where's all kinds of heart-looking issue things? What is this? This even looks, yikes! Wow, this is just amazing. What's going on here? What's going on with all that crazy-looking stuff? Look at this. Now that's light playing off of there. Look at that. That's a heart valve. I'm almost certain of it. And there's a lot of little plumbing issues going on in hearts, and there's packed with blood, as this is. And there's a lot of very tight muscle. Now, it doesn't look like that, though, that I've ever seen. It doesn't have the blocky look like these are bricks. They look just like bricks. Nobody did this. I can't imagine that being done by anybody as a human endeavor. Look at that blue. Now, is that something playing from the light? Like that almost looks blue too. Boy, that's strange. All that blocky looking stuff. And it meets right up with all that blood. I say that's blood. I've seen a lot of blood, and that's, in my mind, I go with blood. This really throwing me off here. Why these cracks are in that, or why that texture is in this. It almost looks like it's painted. There's some kind of change over here. He's coming out of the side now. Whatever the side of this is, I don't know. And there's something else going on over here. Boy, this one's got me stumped. That's the first time I've ever seen that. But you can see, nobody can. Look at the size. These bricks are different than that, and then this, then that. Here, there, they're different. They're stepped on and off, and they're curved. And that's not a human project here. That grew like that. And some of there's a couple spots that look absolutely like a ventricle wall. I mean, right there. You see that? Let me see if... All right, you see right there? That whole thing locked this, I believe, in my mind, this was a vein valve or an artery valve, one or the other. And they have these really abrupt looking little straps coming out of them. Now this looks like it's upside down now. It would have been this way, and the straps would have been going in, and the bucket would have been down, you know, the funnel would have gone up this way. So this would have been tipped over. That's the way I'm looking at it now. And then I believe these must be heart muscle sarcomere blocks. You know, the more I'm looking at it, they have to be. They have to be sarcomeres. They have to be. Let's look at a muscle from a heart. It's not all that different, but the sarcomeres are much more uniform, I believe. You know, they could be sarcomeres. if it was, this is from a heart attack victim, and it's a gooey heart. It's not a stabilized, solid heart. All right, but there's going to be layers in between here that are membranes that separate different layers of muscle, and as it wraps around and does all that stuff. Now, these could be the blocks that we're looking at. Now, are they all exactly the same length? I'm not sure. I'm not sure they are. Especially when they're wrapping and twisting around, and there's a lot of wrapping and twisting going around in a heart. And there was, like I said, like here. This is making itself go into a whole new area. Now, is this part of the tubing? I believe it is. You see it wraps around here and all the way around that other side, and then comes back around this way, and this bridges into here somehow with a seam. And this is a known type of seam. But boy, that crack down the middle of it's got me confused. Although when things stabilize and they harden up in the mud fossil conditions, they swell and they crack, and if it was underneath here, and that block was underneath this, which I think this is sticking up, it could crack there. It's obviously did. So that's, and I'm going to show you this on a heart. This is very similar to the seam on a heart where, well, I'll show you the seam. This could very well be exactly that seam. All right, yeah, I think this is the heart. Up in here, you got all this twisting and so forth. And these are sarcomeres. Now, they can't have exactly the same distance, but they have all these twists and curves. And these are sarcomeres, just like we saw those blocks. Now, there's going to be membranes in between these layers, and then there's going to be a seam that welds these valves. These, the tubing really is up here where those, I showed you those little straight little straps going up. I'm almost sure this is what we got here, is the edge of a heart, the valve assembly up here at the heart. And I believe it's right here. Well, there's a bunch of different tubes. This, I believe, is one of the tubes. Now, there was another tube I showed you right over here, this one right here. Because they're all packed right together. This other tube is right here. And that's strap. You see that? Let me open this up a little bit. You see it? That almost looks like teeth. But that's exactly the way a heart straps come down to what they call the heart strings. Yeah, I'm going with almost absolutely. This is all of the gooey stuff in the heart. This is the right around the valve, and these are what I'm going to show you right now, which is the heartstrings. Now remember all this gooey stuff. Remember these little heartstrings, and they erode away because they're they're not strong. And here's what you got: all that gooey stuff up in here, and then the heartstrings were coming out, and they're broken off. And laying under them is the bricks, which are the heart muscle. So let's look what we know. What we have here now is all of the heartstrings, and I'm saying up in here is all that gooey stuff, and then it's broken off, and then there's a bunch of little valves in this area as well. But these are the strings where they're broken off. I believe that's my take on this right now. All right, right there. All right, so now there's a whole bunch of plumbing going on, and there's a whole bunch of blood going on. And then we come back here, we see where that area is, where we were just a second ago, where those tubes, I think they're tubes. This had to work its way into that tubular stuff, so you have this kind of crazy look to it. But these bricks, I think, are the sarcomeres. I think they are literally the sarcomeres, and they twist and they wrap around because the muscle has to twist and wrap around, but those blocks have to be in here. And the blocks are these blocks. That's what sarcomeres are. They're blocks now. You know, I mean, they're so perfect. It's just hard to believe they could be that way, but you know, you see what you see. All I can say, you see what you see. And that is what you see. There's all the bloody looking stuff. This, I don't think anybody built this. Let's go with that. Let's start from saying, do you think that's possible somebody actually constructed this? I say no, it's not possible. I'm going with that frame of mind right away. And I say, what is this? I say, normally that's what blood looks like to me. It's some kind of fluid that's within the body of a creature. This looks like bricks. I can't say it doesn't. This is a seam that I have seen many, many times, like I just showed you. I think I showed it to you in the heart. That seam is just like this right here. Whoops. We find a heart here. It's just like a seam right there, like in the heart. All right, and this is where it breaks off. The plumbing just comes right off. It's just like almost like it's bolted there. And then there's the valves stick up like this, and that's with those little tongue-looking things. And I think that's what we saw before. Here's what the valve looks like. But you don't see the actual valve-looking stuff. There's little teeth all the way around here, which is what we saw before. Let's see if I can get a better shot of that. Well, all right, this actually shows it a little better. You see over here? All of this stuff is like the little teeth coming down to these inside the valves, and I think that's what we're looking at, some of this plumbing. And then, of course, this is really heavy duty. I mean, your heart is doing this all day long, and it twists. So I could see those blocks being the heart sarcomeres. You know, normally I would look at this, something like this, and say, yeah, absolutely, that's a sarcomere. However, the blocks could be. Because all I can say is we see what we see. And, you know, I appreciate being able to show this guy's video. And you should come up and look at Australian History Seeker. And there's too much plumbing going on here. There's too much plumbing going on. All these holes and all of that blood stuff that was still stuck in here when it died. That's my take. There it is, see? It's not constructed, and whatever this is, I don't know. But that was another little... The human body, the construction of the human body is so incredible. Not a human person on the face of the planet could ever imagine how complicated and elegant it is. How well thought out all of these things are. However this was done, I don't know. But I can tell you what, it didn't come from pond scum. This is some serious work going on here. Every one of these little things, if this is biology, as I say it is, and it is because I say it is, and you can trust me, because I never lie and I'm always right. I'm just kidding, Now, here's the deal. I'm seeing, which I would expect, a layer of Slurpee in between where the muscle has to slide against this other muscle. They're going to have a good thick layer of Slurpee in between all of those layers of muscle. And they are bands. They are bands. They could literally call them bands of muscle. And I just never expected to see bricks looking like that. But, you know, you see what you see, and then you have to decide, how am I going to interpret that? I have to interpret that that's a heart. In my estimation now, I'm going with heart. And this way back here, is the coating outside the heart, which is the fascia that coats the heart. It's going to have this kind of a texture to it. All right, this is the fluid-filled highway just below where the membrane meets the muscle. There's a fluid-filled highway. That's it. I've seen enough of this that I'm pretty well understanding what I'm seeing here. I'm pretty well understanding it. I'd love to have some better shots here and there. Very interesting. Not man-made. I'm going with absolutely 100% not man-made. That I will state. There's no possible way that's man-made. So, maybe this guy could go back out here. We could get a little more detail of this and that. I'd like to see the outside better. There wasn't much on the outside other than this shot here. Or at the very end it shows the outside right here. As he comes out, that's where that membrane was, and he comes out, he looks here. Now what's over here, I don't know. This could, like I say, we got a lot of plumbing going on. That could be another tube. I don't know, but he's right at the very end. So we got this, we got that. I would like to be able to see from distant shots and so forth. But that's it. Thank you, my good friend. Okay, my friends, hold on to your hats. This goes back 10 years ago when I wrote my paper about fascia. And this is the fascia, and these are the tendons inside the fascia. We're going to be looking at this a little closer. And this is when they said vascularization in contradiction with the vascular theory that held sway. This was when everything converted over into the fascia that we understand now as a primary organ in the human body. Okay, this is when I called the fascia one giant network of fluid-filled fibers. And this is what she says. At that time, the theory was different. And it says that there seemed to be a real continuity between the sheaths all over the body. Okay, this goes back about 5 years ago. And they're talking about fascia, the body's remarkable functional glue. Now listen to this. It turns out fascia can do something kind of remarkable. It can change its material properties. It can change them. And I mean it can change it on demand, and I can prove that. When there is an infection, an invasion, the fascia can just basically dissolve and send all of its fluids against that invader. Now this is the size show. They got 8 million subscribers, and like I said, this goes back 5 years ago. And that's about the time that they announced that it was a new organ right here. Meet your interstitium, a newfound organ. It's basically the fascia, but there was one more addition to fascia that they never saw before, which is the fluid-filled highway. And that's the network of these little tiny tubes. They're so tiny they really can't see them, basically. Now, in addition to that, well, they can see them, but they just never paid any attention to it. They thought it was like, they called it fuzz. They said it was just nothing, it was just floppy stuff that tangled all together and sort of made a bumper pad for you. That's basically what it was. However, this layer right here on top of that fuzz, well, this is the fuzz, and it contains the fluid-filled network. And that fluid-filled network contains the enzymes, the ribosomes, the bacteria, all of the catalysts that can attack invaders. They can get in here, that's not a problem, that's just skin. Once you get past that, you're into the good tissue that can feed. Just like it feeds you, it will feed the tumor. The tumor will take off and just start growing bigger and bigger, and then That's cancer. Any invasion has to be stopped right here. If it's not stopped there and gets through and starts attacking you, you will send a ton, and I mean a ton of fluid into that. And you have tons of that fluid. There's 4 times as much of this fluid, which is the interstitium fluid, which is a lymph, than there is blood in you. There's 4 times as much lymph, which is the fluids, than there is blood in you. All right, this is the paper I wrote in 2015. I've shown this a million times, but this was somebody writing about me in a fossil fuels paper. No, because all of this stuff relates to everything that's in the earth. The geology is just totally wrong. We live on biology. I'm sorry, that is a fact. And when I show you the things that I'm going to show you, there is no denying it. As a matter of fact, before I even do this, this is how I wrote about the fascia in 2015. I understood it was, I detailed what it is. It's an entire cellular structure. It's a web of our life. It covers everything. It separates every cell and structure from its neighbor in life and death. That was the preservative that caused my mud fossils to preserve. That's why I call it fascia facilitated fossilization. I said it's all made of collagens and keragens, creative fibers and elastins, the sheet that wraps everything. And then I went on to say how many types of collagens and all that business. And they're infused with silicon. That's very important. 50 times silicon in the skin than other areas because it's so tough and grippy. And then I also talked about it being close to acupuncture points. I think this may, and as I show you the little dots right here on the end of every fascia bag, I think that has something to do with separating the acids from salts and whatever it is. Each fascia bag has its own chemistry. I'm almost certain of that. The only way we're going to be able to find out is from like autopsies or something that can get that fluids that are contained in that bag and analyze them versus another bag. So you do your kidneys versus your liver versus your lung versus your heart, because every one of those is open to its own specific invasion. And the only way it can get invaded is going through that fascia. This is not a big stretch here, and all you got to do, I say all, what we need to do is autopsy tissue before it gets flushed with all chemicals and stuff, and get that what's living in there. What is a healthy one versus a diseased one? If this guy's got a certain type of cancer of the lung, what is in his that is not in the other one? Or what isn't in his that is in the other one? And I would go, everything's done by bacteria and enzymes. So that's where I would go, just to do a bacterial enzyme analysis of every single fabric bag, and every fabric bag is going to coat every organ. That's why there's so many cancers. They're all unique to that fabric bag. That's what I'm thinking now from the research. Let me just finish up on my paper, because this is how I started to understand. By this time, I pretty much fully understood what the fascia was doing. Very hard to bring this to the medical community, because they were not receptive whatsoever of any of my work, because it related to these fossils that show that the timeline of history isn't right, geology isn't right, the chemistry of the body and even anatomy was wrong. They never even knew about that fluid-filled highway until 2018. They finally put a paper out saying, yes, this is real, and it's the biggest organ in the body. Now, listen to what I had to say 2015. Fascia was thought to be mere packing material, virtually inert, long been ignored as a subject of research. Nobody was looking at it. Recently, there's been new equipment that allows viewing of fascia as it does its job. You saw Jean-Claude Berthaud going back and forth with the fascia and watching it do this. There was other different types of equipment that they could see even deeper into the movement of literally way deep down. I could see even beyond that. And I will show you right now. I can actually show you the fascia doing its job, attacking an invader. I can show you that actually happened. They can't do that. I can. See, they're talking about it being able to reconnect, and it does. I said it could even be a fiber optic wired network, redirecting broken wires. Somehow it's communicating with these wires. No question whatsoever it is. I'll show you. It's a cooperative effort. I believe fascia fiber optic style network in creatures connects to every cell, complete system. It is. It's a complete system throughout the whole body. And I had to talk to people all over the world that were sports people, injuries of sports people, because nobody was looking into it for any medical purposes. They were looking into it for injuries and how to stay fluid and movement and be able to flow your body. And that is extremely important. Then I said that, anyway, I went on to say the people I worked with overseas and, the top anatomists and stuff. Nobody was against what I was saying. They just never looked at it before. So I said I look at the chemistry, the studying the fascia. Now here's what you have to explore. I said, what can we explore? How are these rocks formed? This is what I was talking about, is the rocks turning from the body tissue like that. That's meat. That is meat right there. And that's the fascia on the meat. That's the fascia on the meat. Now, how did they do that? How did that happen? How did my buddy here, Caesar Augustus, he's Augustus, there's his feathers. How did that happen? Explain that to me. They all died flat in a flood. And that's why this side is flat. You can see where his neck would have gone, though. You see right up here? It was like a cavity area in there, so it solidified a little bit different. You have to really be able to think what you're looking at when you see it. There's his little nose hole. There's his beak, or bill, or whatever they call it. I think this is a goose. I don't know. I can't find anybody to tell me what that pattern is. You see that pattern right there, that big gigantic flap? And then all the little ones coming off to the sides here. You got to get it in the right light to see the correct patterns, but I think you should be able to see that. I don't know what kind of a bird this is, but I would go with a goose. I go with a waterfowl. And there's this little floppy stuff underneath, and he has an artery right there, which I've done catalase tests on. There's still catalase in there. There's his neck. Now here's the nucleophilic invasion and substitution. What around here, through the membrane, the fascia, which facilitated this fossilization. The fascia was okay. You can go back and forth with that because it does that all the time in your body. You're always transpiring back and forth and bringing in and out things through all of the cells in your body everywhere. If you don't do that, you die. So when you do, in this particular type of fossilization, which is the mud fossils, because it was a boiling hot ocean, MIT admits this now, that the ocean's boiled, and then it boiled the creatures that were here. Now they don't understand the mud fossils. Nobody will look at this because it's too spectacular to embrace. It makes them look like crazy, because the things I show you seem to be crazy, but they are not crazy whatsoever. Anyway, there was creatures our size, there was huge things, there was little tiny things, and so I go through the whole thing about, well, here's the questions you have to ask. How are the rocks formed? How did it happen? What causes the elements, such as metal and such, to concentrate in certain areas where gold happens and copper and all those different things? And I know exactly why. What are the steps in sublimation and solvomorphism, changing things? What's the process that creates fossil fuel transitions? There's a lot of people talking to me about fossil fuel, because I understand it. I understand exactly what happens. And it results in organic compounds and volatiles. How does the pH affect the process of fossilization? What effect does the wet soils have? What are spontaneous electrical potentials, telluric currents? What do they have? on organic matter? What is the molecular structure of different bio areas in the body? Everything's different. The connective tissue versus your lungs. How does the chemistry react during death? What happens when you die, and what happens in the chemistry? And what happens when you get boiled versus when you just sit out there and rot? What happens when you're in water versus when you're in a dry area? What's the process of decomposition and purging of fluids? How does that happen? The fluids in your body, they call it effluent. It just makes a big pattern around you of these bodily fluids. What were the conditions of the burial? Was the guy buried in a box, or was he just buried in the dirt, or not buried at all? What forms of chemical invasions are at play? What chemicals? How does tissues form layers, and how do they separate and transition? Why are there so many layers of tissue? It's because there's a layer of body tissue. What's the process creating voids and vugs? Those are the holes in the alveoli and such. How does metal seeding happen? That's when the crystals form. The process leading to crystals formation, percomorphism, also called solvomorphism. All these little bits add up to, in some cases, exquisite, exact anatomical stone replacement body parts. Exactly. Every structure and every color of the original flesh intact. Now, I was assaulted so badly, I just withdrew everything at that time, because it just was, it was really working against me, I can tell you that. But finally I decided, well, I'm going to come back at it. But anyway, they started to embrace my work. Well, a year later, Yale put out their paper, which is, I had fascia, I just showed you what I wrote. And it was due to the silica-rich oceans. And that's what Yale wrote here, a year later. And actually, I gave all my information to Derek Briggs, who wrote the paper here in 2016. That's a year after my paper. And he says, yeah, it was the earliest, they say it was the earliest creatures that lived. And they weren't the earliest fossilized anything. And they say they were all just soft-bodied. They were only soft-bodied, which means no bones, no teeth, no anything that I'm showing. And I'm showing it all, and I have it all here, and it all has fossilized in exactly the way they say. And it's all, they say it was all under the seas, and that's because there was a huge, great flood. And it killed virtually everything on the earth. Rapid precipitation of silica cements. Well, they didn't precipitate. They came up from the bottom of the ocean because we almost got hit by Venus. Now, they claim, MIT says it was some gigantic thing many times bigger than Mount Everest, and it boiled the oceans. That's exactly what MIT just put out a couple of weeks ago, or maybe even less than that. The oceans boiled, because I've been screaming about this. The oceans boiled, and that's what boiled these creatures. It caused the red bed, the gray clay, and the black cap. The red bed is boiled flesh. It's settled first. The gray clay is all other stuff, and including chunks of body parts. And then above that is the black cap, which is all the fallout from the combustion and volcanoes. I mean, it hit, and it brought up all this silicon, these extreme silica cements. They have no idea why they came up, because that's not normal. They say the only reason they even know about this is because these silica cements came up from the ocean floor. They don't know they came up from the ocean floor. They just say it was a quirk in the chemistry of the oceans. Right, and they're saying that they buried rapidly in underwater, it's like underwater events, and they turned into stone very quickly. And it's all because of the silica. They say what they realized was during a time that much richer in silica. They have no idea why. It starts right out by saying we would never even know about this. This is about the Yale News. It's right from there. We found this, we figured it out. Well, anyway, it says we likely wouldn't know about it at all if not for a quirk in the chemistry of ancient oceans. Well, the quirk was it was saturated with silica. And it says all these lived in a warm, slimy petri dish. No, they're trying to cover their evolutionary stuff. This was just, and they actually say it could have been a failed evolutionary experiment. right down here. Look at this. Are these organisms some sort of failed evolutionary experiment? Yes, they were. The ocean was flooded. It says many of them are outright bizarre in appearance and don't resemble any organism alive today. That's correct, they don't. Because they were giants, they were monsters, there was dragons here, and every single culture talked about them. 100% talked about those same things. And again, I showed this to Derek Briggs. I sent him all my information, over the internet. We talked once or twice, and it didn't go well. And then all of a sudden he pops up with this paper. I don't think that's right. And then NASA paid them to do all this. NASA Exobiology, and NASA Fellowship, NASA Complex Life, that's funded. It was supported by. And I had sent all my information to NASA too. They knew the same story in 2015 because of something that just came up again today, is what they're doing on Mars. They're talking about, we can see we're on slick terrain in Mars. Well, no, they're on dead bodies, and they won't pay any attention to that. You see this? This is what annoys me, and it really does. At this point, it's very annoying. They're talking about NASA's Perseverance rover is on slippery terrain up there. Well, guess what? And this just came out today. It just came in a few minutes ago. Look down here. Well, this is all about, we're driving around up there. We're having a good time. We're looking for this. Boy, we're hoping to find some life up there. We're looking. Well, here it is. More about Perseverance. Their search is for ancient microbial life on Mars. A primary goal of Perseverance is astrobiology. What does that mean? Somewhere out in space, biology. Collecting and storing rock and soil samples that may contain traces of ancient life. Then they're going to bring it back here for another couple of $1 billion. Well, guess what they just brought back? Traces of the same sort of stuff on Bennu. I know exactly what it is. I'll show it to you. And I know exactly what is on Mars, and I have shown it. All right, like I say, this has been many years now. They went out to Mars with this lander, which was called the Curiosity. And it went out there and it saw this Mars crab, and there was a big hullabaloo about this in 2015. And I knew immediately when I saw it what it is, and it is an artery, and that is the vein. And here it is amongst sarcomeres. These are sarcomeres, which is a muscle. And they pull in and out like this, and they need a ton of blood. So I knew exactly what it was, because here's what sarcomeres look like in actuality. This is what sarcomeres are right here. This is from a heart attack victim. But the sarcomeres pull in and out just like that. And they were flush with blood, and they have a seam here and a seam here, which is what's called the phospholipid layers that pinch each block of these sarcomeres. And that's from a heart. That's a heart. Now, guess what they also found? They went out to Bennu, which is this heart. That's a heart. All right, these are the valves of the heart. It has tubes coming out of it. I'll show you those in a minute. They're not craters, they're tubes. And that's what this is, a heart. Same thing, it's identical. Psyche is also a heart. Same thing, identical, same tubes, all the same stuff. And what happens is when these hearts, actually even when they do the autopsies, they just break. There's a little line right across here. They just come apart. That's the plumbing comes off, and you end up with the buckets of blood underneath. And there is just no denying this. This is a heart. And they went and took a sample and came back with it. Now, I showed you what sarcomeres look like. All right, don't forget, these are sarcomeres. This is a heart. Sarcomeres. These are the little muscles that do the job making your heart pump. Well, where would we find them if in the sample that they brought back? Let's see if, because they showed a sample. Here it is right here. Ooh, sarcomeres. Well, how did they get there? Well, I don't know. They're pinched between two layers of phosphates, which they said, wow, this is a surprise. There's two layers of phosphates with sarcomeres inside of them. Gee, I wonder how they got there. Well, it's a heart. That's how they got there. All right, now, this has been here back on Earth for a year now. They claim, what I just heard, nobody will communicate with me. I'm showing that, there's no question. It's here on Earth. It's not like we can't find, and I'm going to show you a meteorite I have here that is also biology, came out of space. The stuff that's in space is biology. I can't find anything that isn't. Comet 67P, 100% certainty. This 100% certainty, look, that's a tube. That's a tube. It's coming out. These are the valves. That is the tendon. These are the colors of blood. Everybody knows the colors of blood if you've been around the mud fossils. It's the red, the black, and the yellow. The red is where it's really got a lot of oxygen, artery blood. The yellow is sort of transition, and the black is when it's depleted of oxygen. I've shown this hundreds and hundreds of times. I had thought by now somebody would stand up and say, yeah, you know what, Roger, we're going to look into this because this makes a change of every single thing that we've thought. But no, it's because of it makes a change in literally everything that we've thought. It will not be looked into because it's too spectacular for the human mind to grasp, especially when we are being told what we have to say by academia in order to get a degree. And I saw a thing all about college now, rethinking college. Yes, you should absolutely rethink it. Get yourself something that is a trade. For them to tell you about space and about the speed of light, no, that's absolute nonsense. Everything they're teaching you in school now, chemistry, history, physics. Well, hold on a second. Here's my little list. What changed? What changed? Geology is just 100% changed. There's no geology, it's just giant biology. So therefore, just about everything changes. Chemistry changes because of the dipole electron flood theory. There's nothing but dipoles. Biology changes because now we know what biology really can do and how I'm going to show you right now the actual lymph system working. It'll blow your mind. History, mythology, religion, anthropology, archaeology, human development, giants, dragons, myths, evolution, everything, the physics, the light, periodic table, the complexity of enzymes within these fascia fluid systems. Literally every single thing that you have ever heard changed. Now, I'm not saying that they were trying to lie to you. I'm not saying, I'm not a conspiracy person. I'm just saying they were wrong. Now, though, they are lying to you. All right, this is from the video I just did, and it's, I don't know, 10, 15 minutes long, something like that. But as I started looking back through it, I'm pretty sure this is blood. I'm going to show you the whole thing, but these tiles and so forth are just amazing looking. And then I saw that, and that to me, that's where it weaves in. This is an abrupt transition. Now, I have a friend, Scott Wiles, who sent me these pictures years and years ago, right here. That's basically the same thing we're just looking at, is that little set of tags coming up here, broken straight off. Now let's look again at it. And don't forget, this is literally glue. I mean, I'm not kidding you, that is glue. And it glues these tendons with an abrupt transition directly to whatever it's embedded in. And it could be virtually anything. Because tendons, everything in your body flexes into a tendon. Every muscle in your body and everything you have runs on muscles. So that's this. Now, what was I showing you before? Where is that tendon? Hold on. All right, here it is. Again, these are those little tendon-looking jobbers sticking into something, just like what Scott Wiles found. And he found those on the coast of Washington, I'm telling you, Oregon. And like I say, this goes back many years. And then Tyson Carlson saw that video, and he lives right in that area, so he started doing some investigation, doing a fabulous job looking into some of these gigantic, huge structures, because as I showed you, what Scott sent me was so big that I said, wow, this thing, those tendon fibers are usually just tiny little fibers, I mean tiny, and what he sent was like gigantic ones. These aren't as big as what Scott sent me. The ones Scott sent, look at that, look at the size of the damn things. So then Tyson went out and he found all kinds of stuff. Here's what Tyson found. Look at this. If you know anatomy, that is a membrane, and that's only the lower layer of the bilayer tendon. There's the top. I mean, membrane. There's the top of the membrane. There's the bottom. It's 6 feet thick, at least. And you see these little flares around all that. At one time, when this was alive, it was all glued around here so that nothing could penetrate it, just like in your body. Nothing can penetrate between there, otherwise you get invaded. That's what I'm talking about, was you need these right here. These bumps actually contain the enzymes. When you look at what the cellular structure is, the top cap of the enzyme, I mean these cells, contains the tight junction catalysts and enzymes, and they're the ones that attack anything trying to get through these flexible joints. The only places that let stuff in and out is here. Those are supposed to be there. So this is one thing that Tyson reported on, and he's found a lot of stuff up there, a lot of stuff. Here's another one. Here's these tendon balls. You see this? This is Tyson's legs here. There's the ball, and you see that little strap going on right there? There's another one over here, the strap running in. They all have little straps on them. I show my belt. I suppose I should show it to you. It's the exact same thing. Identical. The balls have a strap, and then you can pull this way and pull that way and pull this way, and they'll all come back to where they're supposed to be. And here's what it looks like in the interstitium. That same stuff I'm just showing you, those balls are these balls right here. The little brown places are the straps. This, the pinky stuff, is like a gooey collagen, and which holds all the fluid-filled stuff. So, and a mucosa just means skin, fascia. It's the gooey part right above the membranes and stuff. So what do we just see? We saw that. We saw the balls. The balls I'm saying that are in there. We saw the membrane. We saw that crazy looking thing, which was the other crazy looking thing. That's, you know, things are just huge, and nobody can accept it. Now again, Tyson found this. This is 6 foot thick membrane. On us, you could hold that membrane up and look through it like a window pane. You look right through it, no problem whatsoever. All right, we're going to look at some skin. This was from Scott Wiles again. This is human skin, and this is like in stone. Now, that's just not uncommon. Let me show you something here. This right here, whoops. Over there we go. Okay, now, that right there is my belt. That's the surface, the surface of the belt. Now, if we go around the edge of the belt here to the side, you see all those little black balls? You see all those little black balls? Those are the interstitium balls. Every one of those is on a strap. And you see the bottom, the split part? I'm going to show you that straight up. That's where all the balls are. I mean, all the straps are attached to the balls. They roll this flat as a pancake. And I got something to show you that just floored me. All right, hold on. Okay, this is a shocker DuJour, I'm telling you for sure. This right here is the edge of the belt. All right, let me get my little pointer here. That's the edge of the belt here. Now, if I'm going to twist it up a little bit, you'll see there's the thickness of the belt right there. I'm going to give you a better shot of that, which it just floored me, I'm going to tell you that. all of these are those little black balls. What they do when they tan a hide is they put in all kind of solution and then they roll it flat with rollers so that they crush these balls. But on the side, as you saw before, you can see the balls on the side are not crushed like these. Now, however, all of those, if I move over to where my belt buckle attached, you see, every one of those has a strap. All of these straps were attached to these balls. They're everywhere. You just don't see them, they're matted down. All right, you see it? And that's the thickness of the belt. And it's just nothing more than a just gigantic tangle of balls and fibers. Now that's what I showed you from Tyson. He was like standing right next to one, only the ones he had were like bigger than basketballs. Okay, what I want you to look at is these bricks. I mean, they look like they're somebody made a brick, but so does this. It looks like a brick. It's not a brick. This is, I believe, was either a muscle or a tendon. And I'm going to show it to you in a microscope. And you can see there's a different coloration here. It died laying like this. And that is pretty much what tendon looks like. Those little white fibers in there. Doesn't look like muscle. It could be. But I know there's a blood in here because it ran down to here. It died laying on this side like that. All right, and all the blood sort of puddled right here. And if I put a little water on it, you can see the red goes up to this area right up in here. But the darkest is here, so it died like that. But they were square to begin with. So it sort of died with a little bit of a twist. Now, these are as square as they can get. And, you know, they say nature doesn't make square edges. Well, let me tell you something. There's more square edges than you could ever imagine. Now, this is pretty damn near like this. Now, because I believe it's a heart, and remember the stuff that Scott Wiles sent me, damn near the same thing. And these are damn near the same thing as these. And this skin around it is the Slurpee that lets these things slide. When I showed you, or did, or will show you, strolling under the skin, there's a Slurpee around here. And that, you see that? That's a rind, whatever you want to call it. It's right here. I'll show you in the microscope exactly what it looks like. And I broke this off. I have more to this. It was a little longer than that. And I think it's locked in virtually like these lock in at a certain point, which is at the end of this over here. And they lock in with this triangle right there. You see that triangle coming down here and down here. And that, my friends, is the fluid, I believe, that runs from the lock to the next body part. And this is like glued right up into there. I mean, it's just glued like that. And this is where the body fluids ran. And the lock is right up in here. That's the lock right there. And after the lock, it runs into the fluid exchange. And all that was glued onto here somewhere. Anyway, it was all one big piece when I found it. I do my butcher job. And I can see the little stripy looking things in here, like tendonish material right at the very end, and then it just stops. So we're going to look at that in the microscope. I'll show you the blood in here. And it looks just about like this. This plays for, I don't know, 8 or 10 minutes. And I'm going to show you a lot of detail here. It's just we have to really take a look at what's here and understand it. And then we can go on from there, that's all. Things preserved in the most spectacular manner. I've shown this over and over and over. And right there, I'm telling you right now, this is a new body system. These two dots at the end here change from the fascia here, which is the fascia here, and those fluids that protect this, and it moves it into the next organ or whatever. And the next organ might have whole totally different chemistry. So we have to know what's the chemistry in this bag versus the chemistry in the next one, because there's hundreds of types of cancers. Every one of them is related to an organ or a tissue type, and every tissue type and every organ has its own specific fascia. All right, that right there, my friends, boy, I tell you, it doesn't look much different than this. Now, I've never seen anything like this before, so, you know, that's up to you to take a look at it. I don't know, but I see a lot of stuff. I know what this stuff is. That's eroded blood. I'm almost 100% certain of that. This sure looks like the same stuff Scott sent me. And these tiles look like the same sort of stuff as this, only they're curved and so forth. But I believe it's because of it's in a heart. And, you know, I show this in as much detail as I can. You see the ends of those? I'd like to have this guy come up and really look at the details and look for, like, where there's blood, the black and the red, and, you know, like, what's that hole, and what, you know, get right up close, and even maybe take some samples and so forth. This stuff it needs to be looked into. Somebody's got to do it, and the people that you'd think would want to do it have no interest whatsoever. So it's up to you. All right, this is what's cool about doing what I do. I was posting about fascia and all that kind of stuff, and I'm doing this video today about fascia, and this just comes in. A guy in Australia sent me this, and I looked at it, and right away I knew it was some kind of, it looked like fascia. Now, not only did he send me this picture, but he sent me this one too. Look at this. Now watch this. Again, we've got some kind of a membrane, I would say here, and some fascia weaving in and out of the membrane. And why I say it's fascia, wait till you see this. Look carefully. Look at the details. What do you see? There's a million zillion little dots. What are all those little tiny dots? And they're very uniform. You see them over here? They're very uniform. They're just everywhere. And they're little dots, and then those little straps. And those little straps, I'm going to tell you right now, that's fascia. And those little dots are blood cells. This is a body tissue, and it's in Australia, and he sent me this. And he sent me a bunch of other pictures, too. Here's some more of this. Anybody who knows mud fossils, you know, you can't miss this. What it was, I have no idea. But I would say it was pretty good size. All this is blood. Now what that is, I don't know. You know, there could be all kind of debris just laying on here. It doesn't have to all be from the same creature. You know, other rocks and so forth. But you know, when you see this stuff, this is biology. Let's just cut to the chase. Okay, this is again from Rob Humphreys from Australia. And what is this? Well, you know, again, I say look at the details. Look at that stuff. Look at that scruffy little stuff. Can you see that? Look at that straight across looking lines. What the heck is going on there? And then the big slabs or whatever that is. Look at that. It looks like almost like bark from a tree or something, or almost maybe even like feathery looking stuff. Well, what if it was a feather? It would be a pretty good sized feather. Well, what else could it be? Let's think about that. Because they have those little supporting structures in between all of these tiny little fibers. That's why feather dusters are so good at removing dust. They got a ton of little fibers. And look at how it's here and here and here. Now, I think I might have something here that's similar. It's not quite that big, but it is pretty good size for a feather. Now, if this was a feather, look at this. Look at how cool that is. Look at how certainly excellently patterned that is. Well, let's see if I got something here that is similar. And it just so happens that I do. and it's this right here. And this, I think, could be a turkey feather from long ago. It's that color. That's one stud. That's the top. And that's the other side of the feather. This is a one feather. Now, look really carefully. Remember I showed you these breaks, the breaks and the breaks? Look at this. One here, there, and there would have been, you know, another one here, another one here. There was just another slab coming down here. And these are the breaks. And that's the thickness of the feather, one thickness of one feather. And where did it come from? Well, it came from Tennessee, I think it was, or maybe North Carolina. My good friend Greg Morrison sent me this. He sends me a lot of stuff. Excellent source. Well, where did he come up with this? He's just driving down the road and he sees a gigantic pile of feathers. So he comes down here and he chisels one off. I'm not exactly sure where it came from, but you see the same color. It's the same as a... I think it maybe broke it right off of here, somewhere down there, whatever it is. And this, my friends, is not even like a whole chunk of feather. This is like what they call the barbaroles. I think they call them that. These little tiny bits. That thing there is just one of these, what is in between the feathers. It's not a whole big chunk of anything. It's just a little tiny chunk of the tiniest piece that's on there. And I think it's about 3 inches thick. I said, it's damn near like the color of a turkey feather as far as I'm concerned. Same pattern. This good-sized turkey. I'd feed the whole family. Okay, this is just beyond cool. This is that feather in the microscope. And this is that abrupt transition right there. I had nobody cut that. That's just a break. And they got this, and then you got these little tiny fibers in between. And then you got another big block over here. And that's how they pattern. And guess what else patterns in that exact same way? Is that right there. I say that's got to be a feather. Now don't forget, we had the exact same patterns. Let me back this out and I'm going to focus in on this. I say it's the same pattern. Maybe I'm wrong. You see what you think. Whoops. Oh, whoops. This is when Anyway, you see these blocks right there? And all the little ridges in between and the big thing? I just showed you that in a microscope. It's the same thing. And I show it again in this video. I think will be in this presentation. And I think that's just one gigantic feather.